This is Digital Pathology Today. Now, here's your host, Dr. Joseph Anderson.
We hear that multiple file formats, or perhaps more importantly, lack of a uniform file format, seems to be a big issue in digital pathology. Why is this? What do we even mean by a file format? And will we be able to overcome this barrier on the road to full-scale adoption of digital pathology? Welcome to Digital Pathology Today. I'm Joe Anderson. We're talking with Yves Sucaet, co-founder and CEO of Pathomation. Dr. Sucaet holds a PhD in bioinformatics. His research background is in systems and network biology. In 2012, he became intrigued with the idea of applying bioinformatics algorithms to virtualize microscopic material, otherwise known as whole slide images. Back in Belgium, he went on to co-found Pathomation together with Dr. Wim Wellput and Dr. Mark Cox. The mission of Pathomation is to provide software or middleware for digital pathology, allowing any organization to efficiently implement any digital pathology workflow imaginable. We're going to be talking about why there are so many different file formats, what challenges this causes. Do different types of applications necessitate different file formats, aka 2D imaging versus 3D imaging, H&E sections versus immunofluorescence, and so forth? Do evolving technologies and new vendor-specific applications create problems? And what's DICOM? We've all heard about this. It seems to be the most talked about file format. And can we make any comparisons between pathology and radiology in terms of their journey towards going digital and achieving standard file formats? Yves Sucaet from Pathomation, welcome to the podcast.
Thank you, Joe. Good to be here.
Now, tell us a little bit about the history and purpose and mission of Pathomation, if you could.
Well, I'll be glad to. Pathomation was founded in 2012 as a spin-off from a CRO in Belgium. CRO is a contract research organization. The CRO was doing clinical trial work for big pharma companies, and they were starting to receive slides from all over the world in physical form, but also increasingly in digital form. And as they were working with different partners and different places around the world, they increasingly started receiving slides in different file formats coming from different scanners. The pathologists got really frustrated by having to switch software multiple times throughout the day to look at the different files. And one day, me and one of those pathologists sat together and we were expressing our frustration. He thought there should be a better way. I knew there had to be a better way because my background is bioinformatics, actually. We spent 3 months exploring the market, looking at different options, and that's how Pathomation was born eventually. We didn't find a solution on the market at the time, in 2012, that could read all these different file formats, so we decided to set out and build it ourselves. So today, the purpose and mission of Pathomation is to provide middleware for digital pathology applications and provide organizations with the capabilities and the right tools to build digital pathology ecosystems.
Oh, wow. Okay, I think this is very exciting times for pathology and pathologists, and a lot of us are maybe a little unfamiliar with all these technical terms. I think we all understand what file formats are. Like if you take a picture, it could be saved. There's many different formats like a JPEG, a GIF, there's Adobe PDFs. There's all different kinds of ways you can save a file or present the data from a file. And it seems to be an issue that keeps cropping up again and again and again. And some people would even say, well, this is even the biggest impediment or barrier to implementing digital pathology as well. It may work in your hospital or your system using your hardware and software and your file formats, but then when we want to start realizing some of the promise of digital pathology, everyone using different file formats just is not going to work. So maybe could we start from the beginning? Why is this such an issue? Why are there different file formats, and what are the various file formats, and what exactly do we mean by a file format in the context of digital pathology?
Well, a file format, like you say, indeed, you can compare it with the file formats that we're all familiar with by now. If you open up a spreadsheet in Excel that's stored as an XLS file, that's a file format. The same thing goes for your camera, right? If you take a picture with your phone and you send it to me, typically that picture will be sent in JPEG. If you have a high resolution camera, sometimes it will be stored as something else, as a TIFF file. But you can have TIFF, you can have JPEG, you can have PNG, but that's about it. I mean, cameras have been around for a long time. Those formats have been defined for a long time, and some have risen to the top and have become de facto standards now, like JPEG. Now, when they first started doing digital pathology, they indeed adopted the traditional formats like TIFF or even JPEG, but pretty soon it turned out that the images that you generate in digital pathology are so big that you need other approaches to store that data. JPEG is limited to 32,000 by 32,000 pixels, and an image in digital pathology can easily be 100,000 by 50,000 pixels. So you can't store that in a standard file format. And you can't load such a big picture in memory in just one go. And even if you could, no screen in the world would be big enough to render it anyway. So what do? You put a tile server in between the physical file that represents the virtual slide and the web browser or whatever viewer software you have available. The tile server is then able to extract little pieces of the original image one by one and piece them back together on the screen as if you are looking at one individual image. So the trick is to get all these pieces, and the pathologist, like you say, should not be able to notice that you're doing this trick behind the scenes. Google Maps, for instance, if you've ever used a mapping software, Google Maps or Street View works the same way. But they do it with satellite images, right? You never see the entire satellite image, but as you move the mouse up and down or you pan it around the map, you end up seeing exactly the right piece of the original image that you want to see when you want to see it. And that's essentially the same thing that our software does for virtual slides. So our PMA core tile server works exactly like that. You move the mouse around and we extract the correct field of view for you.
Okay. So what exactly is middleware? I mean, it sounds like, intuitively, it's a piece of software that resides or functions between two other pieces of software.
Yeah, exactly. And that's exactly what we want to do. There are vendors out there that think that they're going to just sell you a monolithic piece of software that solves all the possible digital pathology problems. We've always acknowledged that this is not going to happen. You can't build a single piece of software that solves everything. It doesn't exist. Microsoft makes an operating system, Windows, because they don't have all the answers to all the questions that people want to address with software. HP and Epson and a bunch of other companies, they make printer drivers. And that's middleware that sits between the hardware piece, between the printer and the end user software, something like Word, where you want to print a document from. But HP only makes the driver. They only make the middleware that does the communication. The middleware is the piece of software that takes source data from somewhere and sends it to someplace else. And that's what our tile server in essence wants to be as well. It's a piece of, we address that very specifically, we address that very accurately by providing a bunch of plugins, for instance. So we don't want to compete head to head with Visiopharm or Indica Labs, for instance, which are the go-to image analysis software programs out there for digital pathology. But if you want to just take your pixels from your scanner, from any scanner in the world, and you want to send them to an open source image analysis program like ImageJ or like Anaconda or scikit-learn in Python, or you want to do deep learning with PyTorch, we have a plugin for that. So again, we don't reinvent the wheel. We don't do our own file format. We don't do anything of that. But we are the go-to company if you want to take your pixels from any scanner in the world, from any collaborator, and you want to send them to any other location, any other destination. You want to plug them into any scenario where the people to talk to.
I see. So is this generally necessary if you're going from, say, an Apereo scanner to a different system for image analysis or viewing? Is it a foregone conclusion that you're going to need some form of middleware?
I would think so. I often say to our shareholders as well, they always want to see things move faster, increase our customer base. And I sometimes explain it as Pathomation really is a second line treatment for a problem and for a challenge. For instance, this is what you do with a lot of diseases in the clinic, right? Like you start with an initial therapy and then the patient develops resistance against that therapy and you move over to a second line therapy. And so that's what we are. Like we get approached by a lot of people that say, oh, we've tried this already and we've tried this already, but they promised us the world and we drank the Kool-Aid, but it doesn't work. And we realize now that it's a lot more complex than what we originally set out for. And so Pathomation is kind of like that second line treatment for pathology.
So you're kind of bridging the gap, or you're continuously bridging the gap between the scanners or the pixels and the ultimate usable function that the users need, right? Either image analysis or viewing.
Yes. So whether you have 20 slides that you want to show to your students for a course, or even say that you're teaching general biology and you do one microscopy lab in the whole semester, we have a solution for that. Now, on the other hand, when you're a pharmaceutical company and you want to train healthcare professionals to accurately assess a new biomarker for a new oncology treatment, and you want to issue certificates to those people and keep track of who did the training when, and you want to do that in a FDA-approved manner and 21 CFR Part 11 compliance and everything, we have a solution for that as well. So we really span the whole spectrum. And we're able to do that because we don't sell monolithic software. We sell different components and we can couple those components. It's like Lego for digital pathology. We put the bricks in the right order to build you either a helicopter or a car or a house, whatever you want. Yeah.
Putting the bricks in the right order. That's fantastic.
So part of the reason why there are so many file formats is just out of necessity. The engineers at the various companies that make the scanners had to come up with real-life solutions that could not only store the data, but that were also suited to read the data effectively and fast and show the data in an efficient manner. And that's how everybody kind of collectively ended up reinventing the wheel at different places around the world, and why you see different formats from Aperio, for instance, compared to 3D Histech, compared to Motique, and et cetera, et cetera.
Okay, that's an interesting way to put it. People went about collectively reinventing the wheel on their own. You know, we don't want to think that there's bad people with sinister motives, but why did people think they had to do it by themselves instead of in a more collaborative way, or moving towards an industry standard early on? I mean, was it just like a lack of vision, or they thought, you know, their system is ultimately going to prevail and everyone else is going to need to conform to them? So why is that? And then secondly, give us an idea of the pain points that we're experiencing because of lack of standardization.
Why they didn't all sit together, let's do this. A couple of practical reasons, just the way all of this was created. In a couple of cases, these scanners come from the typical photography, the camera manufacturers, right? Leica has been around. They make lenses for microscopes as well as for satellites that they send into outer space. Olympus makes lenses and cameras. So a lot of these companies, probably because of their size, thought like, oh, we have the experience, let's just do it ourselves. It's just easier to do it this way than to try to sit around. And technology evolves fast. They needed to have a solution right then and there, and standard development takes time. And then the first pain point is that for a lot of scanner vendors, you need to download a special dedicated viewer. That's the first pain point. You need to install the software. The second pain point is not that obvious, but the second pain point probably comes from that you have pathologists that are used to looking through the same microscope to different observations, to different types of tissue all day long, but at the same time they manage to make the right diagnoses because they keep using the same tool. Now all of a sudden they have to look at 10 biopsies in this software, and they have to look at 20 biopsies in that software, and another 15 biopsies in yet a third software package maybe. I don't believe that's necessarily good for the end result in terms of intra-observable replication capabilities of the individual pathologist. That's definitely a pain point, apart from the frustration. I don't think that the field of pathology and medical diagnosis is benefited from changing software the whole time throughout the day. So we're trying to address that by providing a universal piece of software.
So you mentioned wanting to drive towards a unified file format. How realistic is this? Are there always going to be vendors out there that want a closed system? I guess notoriously most like Apple.
The most frustrating is actually the companies that are flip-flopping, right? There are companies in digital pathology that they were very open in the beginning, but they're very closed now, and vice versa. And there's companies that sometimes open up a little bit and then they close down again, et cetera, and they keep changing their strategy. That's very frustrating.
So is it possible we could end up with maybe not one unified format, but maybe two or three, like Coke and Pepsi or Apple and Windows?
We are in touch with a number of small startup vendors, and we do see these companies doing things different. We do see these companies ask us for advice actually on, hey, this is the kind of data we generate. What other file format should we look at? Because there's enough file formats. We don't want to come to the market with yet another file format. We don't see that as a competitive advantage for us anymore. So there is some evolution going on. Now, I would say there are three standards today. There are TIFF-derived formats, and that's, for instance, SVS from Aperio is one of those. SCN from Leica is another one of those. You have Omero, is a standard format that's used by a number of platforms that comes out of Jason Svedlow's group in Dundee in Scotland. And then the third one is DICOM, right?
Yeah, that seems to be the one that everyone's talking about, or they hold out hope like that could become the standard.
Yeah, everybody's talking about it, but at the same time, there's a huge discrepancy, and it's not ill will, it's just the nature of the system, the nature of the mechanics. There's a huge discrepancy between the pace of progress in the technology sector, the resolution at which things are scanned, the number of channels that are being recorded for multispatial observations, and then the pace at which standard formats are being determined and defined. Several big vendors that are serious about digital pathology, they completely revamp their file format every couple of years because it has to be able to support different characteristics now because their technology has evolved. And that's always going to be hard for any standard to keep up with.
Yeah, so it's kind of hard to parse out all the reasons for this, but I think certainly you don't want to discount how difficult this is and all the work that has gone into developing these systems, which you might call proprietary, and then maybe try to parse out, well, how much of that is because that's how they've optimized it versus, wanting to keep it close-ended for sales and marketing type reasons, but then also what about just practical reasons, like as we move into different applications, that there have to be different file formats. So
yes.
Say like for looking at H&Es, looking at fluorescence, looking at various immunohistochemical stains. I mean, there's a lot of players in this universe, right? So we have companies developing antibodies and stains that are often in-house with the companies that develop the scanners, so there's certain big vendors like that. So all of this, it's tricky. And I would imagine that just by the nature of what we do, it may require different formats.
Yes, absolutely. I just mentioned the Omero file format coming from Jason's group. It's even more complicated than that. The type of storage plays a role as well. So the Omero TIFF format has been around for a few years now. But the big thing in storage today is cloud storage, right? Everybody knows Amazon, of course, AWS, Amazon Web Services. When you store data there, it gets stored fundamentally different than when you just have it on your hard disk. So what the Omero group did now is they didn't quite throw away the OME TIFF format, but they just started over and they just came out with a new file format called ZARR, Z-A-R-R. And that's a file format. It's an open community file format, but that's a file format that's optimized for cloud storage and for handling virtual slide data in a cloud setting. So the evolution just keeps going, and this is a discussion that Jason's taken the lead in now, but I've never even heard about this in the DICOM groups before. technology keeps evolving, and it's hard. It's hard to keep up with.
Yes, I mean, that paradoxically, that's what we want. We want technology to evolve. We want to become better at doing things. We want to develop new capabilities to further discriminate among and between patients, but that comes at a cost. So how big of a challenge is that going to be, keeping pace with just simply evolving technology?
Well, we are lucky with regards to the file formats, of course. People want to have their file format supported. And in recent months, we've actually seen an influx of new file formats. I mean, we thought that after doing this for almost 10 years, we'd pretty much have the file format thing figured out, right? No, this is not true. The benefit that we have is that people contact us now themselves and say, hey, can you support our file format? We see some big players even that have approached us now and say, hey, we're actually curious about how we perform, how we stack up against the other formats out there. Can you do some profiling of the performance of our format? And that gives us early access to the specifications, of course.
Yeah. Okay. So let's talk about DICOM. What is DICOM, and why does it seem to be the most talked about format, and why do people hold out so much hope for it?
DICOM has been around for a long time, obviously, and has been particularly successful in radiology. DICOM stands for Digital Imaging and Communication in Medicine. But one of the things that struck me is that a few years ago, I went to an international DICOM conference. 75% of the attendees were actually coming from only 3 companies. So in DICOM, there's always been a couple of heavyweights in the marketplace that can and have made all the difference. They were probably also lucky in the beginning that things moved relatively slow, which is, radiology is radiology. It's black and white imaging. In my book on digital pathology, I actually have a chapter that says it's not like radiology. And this is one of the reasons, because the data originally for DICOM was simpler. The original application for it were limited. They've grown steadily over the year, of course. I mean, a radiology department is not just black and white RX of broken bones anymore. It's a lot more. It's been expanding into medical imaging. There are people that think that everything in medical imaging should be DICOM. I don't necessarily support that. I think that's going to be very difficult to achieve. DICOM definitely has its uses, and being able to exchange certain data in a standard way is great. But having everything DICOMized, I'm not sure if that's ever going to be possible. And you see that with the traditional vendors as well. Historically, only a few years ago, we were still talking about PACS servers, picture archiving, and communication servers. But nowadays, there's more talk about VNA, vendor-neutral archives. And then you're talking about kind of like what we try to do. We want to be the VNA of choice for digital pathology, right? But in a broader context, a true VNA, a true vendor-neutral archive can handle DICOM, can handle just about anything else coming from anywhere. Could also handle genome data, for instance. I mean, that's the thing, like medical data is not just imaging. There are other data sets out there, and how do you treat them? How do you handle those? How do you organize all of those in the context of a patient and a case, which is eventually what you want to do. You want to integrate all of this to cure the patient, right? And that's challenging. Now, going back to DICOM specifically, the way they work is in order to address certain applications, they typically create a working group around a certain subject. So for digital pathology, that's work group 26. So DICOM work group 26 was specifically founded to handle digital pathology. One of the things those work groups do is that they define supplements on top of the standard specification of DICOM. So they define supplements on top of the standard. And then for digital pathology, supplement 145 is the one that deals with digital pathology. And indeed, just like you pointed out, you see ongoing discussions then in that work group about, oh, wait, this scanner vendor came out with this kind of property or this kind of data, or wait, they're doing this now. How can we add that? How can we support that in DICOM going forward. But again, as I said, the standard will always run a little behind on the technology. And I think in order for any standard like DICOM to be successful, the technology has to stabilize more and almost reach a stopping point where we have a pretty good clue about, well, this is everything we'll ever be able to do with digital pathology, or at least for the next decade or so.
It's very tempting to try to play that game. It's like, okay, why don't we just say that this is the standard, or stop now and say that this is how it's going to be forever, right? Which ultimately never works.
Yeah, and I remember this from the 90s. I mean, in the 90s, we had Windows 95 come out, for instance, right?
Right.
And so what we're doing now with digital pathology, we had that with digital images in general back then. And just like you have a universal viewer for digital pathology now, back then in Windows 95, we had universal image viewers. You know, there was BMP, there was PCX, there were a whole bunch of those. And eventually JPEG and TIFF emerged as the standard. But that wasn't always the case. But what's interesting about that evolution too is that it's not necessarily the community standard that won. It was usually a specific vendor's format that just turned out to be more successful and more versatile than any of the other formats out there. And then everybody just began to adopting that. And we're seeing that a little bit today in digital pathology, for instance, with the SVS file format from Aperio.
Okay. Yeah. I mean, that does seem to be a natural and palatable way of doing things. Let the natural winner emerge.
It's natural selection. It's evolution.
But I think the concern is that doesn't seem to be happening, or we're very impatient. We need it now, right? That maybe the natural winner will emerge someday, but that day isn't anytime soon. Where are we on that?
We're not there yet.
Okay. Yeah,
I don't know. That's again, that's all I can say. And I think what makes this problem unique is the nature of the data. Going back to the image formats, right? Say that I have 10,000 PCX images from back in my Windows 95 days, for instance. And today, hardly any software can do PCX anymore, but I can convert all those PCX files that I still have probably in a couple of hours max to JPEG. It's not a problem because they're not that big. But for digital pathology, if I have a repository of maybe 2 million slides, like some people have now, if I have a repository of 2 million files in a certain format, converting those files overnight, that's not an option. You're talking about terabytes or even petabytes of data. You can't just convert those overnight. I mean, that's historical data and you have to keep it around.
Yeah.
And that's a unique aspect of this problem, that what do you do with the historical data? We were recently contacted by a couple of institutes simultaneously, actually. Olympus WebView. Olympus had a file format, WebView, that was used to present slides in a web browser using the Adobe Flash browser plugin. Now, Adobe Flash hasn't been around for a few years now anymore. So Olympus decided, well, you know, the new software, Olivia Viewer, we're not going to support the WebView format anymore. But instructors all around the world have gone through a lot of pains to build their educational collections on a limited budget, on a shoestring budget oftentimes. And they still have the data, because a brain cell doesn't look different today than it did 10 years ago, than it did 20 years ago, or 100 years ago even. But what did they do with their files? They can't show them to their students anymore. So at the same time, at Pathomation, we work on implementing the new cloud-based format, the ZAR format, for instance, which is cutting edge. But at the same time, we also support the Olympus WebView format now, because that helps people out that still want to access and distribute their historical data.
Right. Yeah. So let's talk about that. You know, there's many aspects to digital pathology, and what may go overlooked is archiving the past, which is a crucial component of pathology. There's institutions have millions upon millions of slides, literally. We're doing an episode on the Joint Pathology Center, which used to be the Armed Forces Institute of Pathology in the United States, who's undertaking a massive project to archive the expertise of that institution going back almost 100 years. So first of all, and making these comparisons between pathology and radiology, is archiving the past a more unique problem to pathology, either because A, cases are more interesting for teaching purposes and so forth, and B, we need to train future systems for computational pathology and AI. Is archiving the past more important in pathology compared to radiology?
I think it should be easier to archive the past because you can go into that basement and you can get the historical slides from the 60s or even older, and you can just put them in a scanner and scan them. It works. I mean, we've done this in Brussels for a very important diabetes collection, the Willy Gebst collection. There's a website for that, actually. You can't do that in radiology. You can't go back to the patient that was alive in the 60s, get him in that same physical condition and put him in a tube and digitize the observation. You just can't do that. So on paper, at least, it looks easier for pathology. But the complexity is in different areas, right? I mean, in every step of the process, there's almost something that can go wrong. You need the people to feed the scanners. I mean, that sounds trivial, but when you're talking about hundreds of thousands of slides or even millions of slides, it's not that trivial anymore. So you need people to feed the scanners. You need the scanners themselves, obviously. Then you need the storage space, which is becoming cheaper every day, partly thanks to new technologies like cloud technology and cloud storage. But then, last but not least, you also need very efficient databases around that, because now you need to be able to efficiently search for something in that huge pile of virtual material. And that's not trivial either. When you can address all of those needs sequentially, then your project has a chance of success. But unless you have all those ducks in a row, it's quite a daunting problem to tackle.
Yeah, it's not trivial, as you outlined, for many reasons. And I mean, the archives in pathology are incredibly important. But then on the other hand, is it maybe less threatening to develop what you were talking about as vendor neutral archives, right? Where, we're just going back to the basement to digitize these slides. And can you get more cooperation and teamwork in terms of developing these vendor neutral archives formats?
For small collections, yes, that's definitely true. Obviously, this has been documented. This has been described in the literature. Both in Europe and in the US, you're faced with an aging population of practicing pathologists. If you approach any of these people individually and say, a lot of these people have built interesting collections over their careers throughout their active professions. And if you approach any of these people individually and say like, hey, I can make you famous for next generation of incoming doctors, incoming physicians, let me digitize your collection for you and put it online. And we've done this for a couple of people, actually. Nobody's going to say no to that, especially if you do it as a demonstration and you do it for free. The problem is when you want to do it at an institutional level, when you want to approach the pathology department itself, because then all of a sudden every slide supposedly is going to be the slide that's going to finally make the AI algorithm work, and that somebody's going to make $1 billion for, and therefore the slide is worth $10 billion,
Okay.
There are ways around digitization at a small scale that make it doable and easy to do and convenient, and the low-hanging fruit is absolutely in education. But when you get to talking about AI and training those systems on real clinical data, a lot of almost political hurdles and commercial conflicts of interest show up. And the most famous one is probably 1 or 2 years ago with Page AI in New York, right? There was a huge fallout from that.
So it's not as innocent as you might think, and people are increasingly becoming aware of the stakes involved in digitizing large collections.
My background is bioinformatics. I got my education originally and my training with things like identifying genomes and identifying genes in Saccharomyces, in Homo sapiens, the human genome, obviously. There's no question that somewhere in all those slides, there's knowledge that's valuable and that can be unlocked and monetized somehow. The challenge is to put a realistic value on what you're doing today or what you want to do today just by digitizing a slide. I mean, how much is that really worth? Like, how much can you assume to get out of that and contribute to the bottom line of some pharmaceutical company, maybe 10 years, 20 years down the road? That is extremely hard. But that's capitalism, so,
Yeah, it is. It is a little nebulous. All right. So before we wrap up, I think the question a lot of people want to know is how come DICOM worked in radiology and not pathology yet? There's lots of glib talk that radiology's 15 to 20 years ahead of us in terms of going digital. We've done episodes on this before. I think there's a lot of reasons, and maybe that's not even the correct way to look at it, but it seemed to work for whatever reason. Is radiology just simpler?
It is simpler. It is simpler because there are less devices out there. I mean, I can have a slide scanner here on my desk right now. I cannot have a CT scanner in my office. It's not big enough for that. It's simpler because of that reason. There's less variability. There are also fewer steps involved in the whole process. You put a patient in a tube, and of course the scanner is calibrated, but you put a patient in the tube and you make the observations. And radiologists will fight me on this statement and say, well, it's not that simple. But just make the comparison with pathology, where you have to have a piece of tissue. You have to fix it. Depending on the fixation duration, you're going to have certain artifacts show up in the tissue. You have to embed it in paraffin. You have to slice it into sections. The thickness of the section has an effect. Then you have to stain the slide with specific antibodies, like you pointed out. And then if all of that goes well and you put the right thickness of cover slip on it, then you get to digitize that slide. Now, even with auto stainers and everything and automatic sectioning equipment, embedding and everything automated as much as possible, that's still a lot of variation and a lot more variation that you're introducing than you could ever do in radiology. Technology is also evolving more rapidly for pathology now than it was for radiology back in the 80s. And the data is also similar because you're just talking about black and white. Sure, they went maybe from 8-bit black and white to 16-bit black and white, but there are entire groups around the world in digital pathology that today they do nothing else but study how they can make a slide that comes out of an Olympus scanner look like a slide that comes out of a 3D Histech scanner, or vice versa. Nobody knows what the golden standard is here. We just have the hearsay almost from the pathologist that's looked through his microscope for 10 or 20 years, and that's just harder.
Yeah, it is increasingly complex. So Yves Sucaet from Pathomation, thank you so much for being with us and discussing file formats and the challenges we face. So on a personal level, tell us a little bit about yourself. How did you get interested in digital pathology?
So I was working at a CRO. I was working at Histogenics in Antwerp, in Belgium, of all places. So around the time that we started with this whole Pathomation initiative, in 2012, I got to attend the Digital Pathology Association's meeting in Baltimore. And that's a very memorable meeting because part of the meeting we were locked up in the hotel. We weren't allowed to go anywhere because Hurricane Sandy was coming through. So everybody that went to that conference still remembers that conference because of that reason. But there was a keynote there that talked about using bioinformatics to determine automatic Gleason scores in prostate cancer. And I was sitting on the front row and I was just fresh out of college, just fresh with my PhD, mesmerized by this guy's talk. And I was just listening to it and I'm like, wow, you can do that? I want to do that. I want to make that my mission. This is my place that I'm going to carve out in the scientific world. Then we just found our niche with this file format conversion problem, and the rest is history, as I said. But that's how it all started, like that one single keynote speech that I attended in Baltimore in 2012.
Yeah, that's a great story. I think it is good. Like, who knows what's going to light the spark in you? But it always comes back to that memorable moment when you first knew that this is what I was supposed to do.
Mm-hmm.
So what excites you? Where do you see the field going in the next 10 years or so?
What excites me, I'm building the company now, right? So I was promoted to CEO last year. And we have a team of about a dozen people now around the globe. When I started this in 2012, it was just me by myself in Belgium and a couple of offshore developers. Now I have a team here. I have 3 local people working for me in Belgium. I mean, seeing that grow, that's a validation of, okay, our software is wanted, our software is desired. We're still fully independent. We have not raised any venture capital. It's all organic growth, and just seeing people get use out of our software, that's the biggest validation for me. Our free software is used in over 400 locations around the world each month. That's just a huge boost. That's just a huge validation of, yes, I'm doing something useful.
Yeah, validation in more ways than one.
Yes.
Our guest has been Yves Sucaet from Pathomation. We'll see you next time on Digital Pathology Today.
This has been Digital Pathology Today. Please be sure to subscribe. Thanks for listening.